Good morning, students. Can you hear me? The last lesson, we learned about Haber process and fertilizers. Let us do a quick recap of what we learned in the previous lesson, and then we will move on to today's lesson. Okay. So after the recap, we will be learning about the properties and uses of sulfur, sulfur dioxide, and sulfuric acid. That will be subunit 9.4. Okay. All right. So let's look at the first question. What is Haber process? Can anyone answer? Okay. Haber process is the process whereby ammonia is manufactured. Okay, correct. Next question. Name the reactants for the Haber process. Anyone? Good. The reactants for the Haber process are nitrogen and hydrogen. Correct. Moving on, question number 3. Where does the nitrogen come from? So for the Haber process, where does the nitrogen come from? Anyone? The nitrogen comes from the air. Correct. Good. Where does the hydrogen come from? For the same process, where does the hydrogen come from? Natural gas. That's only part of the answer. Give me the complete answer, students. By reacting natural gas with steam. Okay, so it's not only natural gas or it's not only steam, it's formed by the reaction between natural gas and steam. Okay, good. Whoever answered that completely, well done. State the conditions for the Haber process. So we learned that there are 3 conditions for the Haber process. So state the 3 conditions. Here, you should not give the conditions as just high temperature, high pressure. You will not be given mark. You need to give specific conditions for the Haber process. Okay, anyone? Okay, good. We start with the temperature. What is the temperature? 450 degrees Celsius. Pressure 200 atmosphere. Catalyst iron. Okay, well done. So whoever answered all the 3 conditions correctly, good. Okay, and remember, you need to give the specific values and not just high pressure, low pressure, just catalyst like that. Okay, all right, so let's move on. The last lesson, we also learned about fertilizers. Okay, so we learned about 2 types of fertilizers. What are they? The 2 types of synthetic fertilizers. Synthetic means man-made. What are the 2 types of synthetic fertilizers? Good. Nitrogenous fertilizers and NPK fertilizers. Okay, well done. Let's move on to the next question. Why do plants need potassium? Okay, I do see a few answers. Optimal growth, support growth. Now these answers are quite general, students. We learned that nitrogen is needed for healthy leaves. Phosphorus is needed for healthy roots. So what is the specific need for potassium? Okay, good. Who answered that? All right, yes, potassium is needed for leaves and fruits. For the fruits and flowers. Okay, to have better growth of, to have fruits with bigger size or with more flowers. Okay, so potassium is needed for flowers and fruits. Okay, good. Okay, question number 8. What is NPK value? Okay, I do see a few answers. All right, good. NPK value, it is the value that tells the farmer how much of nitrogen, phosphorus, and potassium is present in the fertilizer. Okay, so it is a value that tells the farmer how much of nitrogen, because we're talking about NPK fertilizer. So nitrogen, phosphorus, and potassium are present in the fertilizer. Okay, good. All right. How is ammonia converted to ammonium nitrate? From ammonia, how do you get ammonium nitrate? We learned that most of the ammonia is converted to make fertilizers like ammonium nitrate. Okay, good. Ammonia is reacted with nitric acid. Okay, so those were some of the questions for us to recap what we learned in the previous lesson. Now let's move on to today's topic, that is Unit 9.4. So the last class we did Unit 9.3, that is ammonia and fertilizers. And today we will be doing sulfur and sulfuric acid. Okay. Now, before that, I would like to ask you a question. What is the symbol for sulfur? Symbol for sulfur is S. And do you think that sulfur is a metal or a non-metal? Sulfur is a non-metal. Okay, good. So let's proceed to the notes. Okay, I have shared the link for the notes with you all last lesson and also in your class WhatsApp groups. Okay, so please download and keep the notes. I have already printed the notes. When you get back to school, I'll give you the hard copy. Okay, so let's move on to today's lesson. So to begin with, just as you said just now, the symbol for sulfur is S, and it has an atomic number of 16. So in which group of the periodic table will you find sulfur? In group 6. Okay, good. So as I said just now, sulfur is a non-metal and it is a solid at room temperature. It's not a gas or it's not a liquid. It is a solid at room temperature and it has got a bright yellow color. Okay, so these are some properties of sulfur. Okay, you have learned this before, just to remind you. Okay, now sources of sulfur. Source means from where you obtain that, from where you obtain it. Sources means from where you get the sulfur. Okay, so source means from where you get any substance, but here it is sulfur. Okay, the major source of sulfur is from under the Earth's crust. Okay, it's found beneath the Earth crust in volcanic regions and so on. You'll find it in the Earth's crust, and this is the major source of sulfur. Now, sulfur is also found together with fossil fuels. Okay, so examples of fossil fuels are, we look at examples of fossil fuels. Coal, petroleum or crude oil, and natural gas. So these are examples of fossil fuels. So as we saw earlier, most of the sulfur is found under the ground. So these fossil fuels are found under the ground. So what happens is the sulfur gets attached to this fossil fuels. So these, for example, when you take petroleum, before it is sold to people, it will be purified. Okay, it will be refined. So during the process of refining, the sulfur will be separated. Okay, so these are other sources of sulfur. Okay, so here from natural gas. Okay, so natural gas, the last time I told you, natural gas is methane. So it's found together with fossil fuels basically, and it is formed as a result of the byproduct of the refining of petroleum. So these are some places where sulfur can be obtained. Any other use of sulfur that you know of, students? Okay, some people believe that, placing sulfur powder, when it is placed at home, in the gardens and all, it will chase snake away. It can, because the snakes, when they come in contact with the sulfur, their skin is irritated itself, so the snake will not return. But we are not sure how far it is true. Okay, so anyway, let's look at the uses of sulfur as in chemistry. Okay, so the major use of sulfur is to produce sulfuric acid. Okay, to produce sulfuric acid. Now, what is the formula for sulfuric acid? Who remembers the formula for sulfuric acid? H2SO4. Okay, good. All right. Now, sulfur is also used to vulcanize rubber. Now, rubber is a natural product that is obtained from plants. So, from rubber tree. Okay. So, naturally, rubber is a soft substance. So, to make this rubber harder, some sulfur is added to the rubber. So, this is called vulcanized rubber. You don't have to go into the detail of that chemistry there. You just know that vulcanized rubber is rubber to which sulfur has been added. Now, what happens to the rubber then? This makes the rubber harder, and this makes the rubber hard and tough, and it can be used for more purposes like making car tires and so on. Okay, so vulcanization of rubber is another use of sulfuric acid. Other than that, sulfur. Other than that, sulfur is also used to make dyes, fireworks, fungicides. Okay, so the other day we came across dyes. Dyes are chemicals that are used to add color to our clothing and other products and so on. Fireworks, I'm sure you know. Fungicides are chemicals that kill fungus. Okay, fungus. Can you give me examples of some fungi? Okay, mushrooms, molds, all these are examples of fungus. So uses of sulfur are quite easy for you to remember: to make sulfuric acid, to vulcanize rubber. These are the major uses. Other uses are to make dyes, fungicides, etc. Okay, now let's moving on. Let's look at sulfur dioxide. Okay. Now, what is sulfur? Now, who can tell me how from sulfur can you get sulfur dioxide? From sulfur, how can sulfur be changed to sulfur dioxide? Sulfur plus oxygen. Okay, so though in the equation we put sulfur plus oxygen, when you write it for your classwork or for your exam, you have to say sulfur reacts with oxygen, or sulfur burns in oxygen, okay, to form sulfur dioxide, like carbon dioxide, sulfur dioxide. Okay, so let's look at the properties of sulfur dioxide. Now, sulfur dioxide is a colorless gas. It is a water-soluble gas, and it forms when sulfur burns. Okay, so when the sulfur burns in air, the sulfur will react with oxygen to form sulfur dioxide. Now, sulfur dioxide is a poisonous gas, and it has a strong odor. Odor means smell. Okay, odor means smell. It is a poisonous gas because it can irritate the respiratory system. It can irritate the lungs. So, and it can, especially people who have diseases like asthma, it can even make it worse for them. Okay, so it's a poisonous gas with a strong smell. Now, how is sulfur dioxide formed? Sulfur dioxide is formed naturally during volcanic activity, volcanic eruptions and so on. Sulfur dioxide is formed because there is sulfur, all right, sulfur under the ground. So due to this high heat there, the sulfur will burn to form sulfur dioxide. Okay, so that is how the sulfur dioxide gets into the atmosphere. But the major source of sulfur dioxide is during the burning of coal or oil. Okay, so oil here refers to crude oil or petroleum. Okay, so earlier we saw that sulfur is found mixed together with fossil fuels. So when the fossil fuels burn, the sulfur will also burn. Okay, so what is the, here it says burning of coal. Where is coal burnt actually? Coal is not charcoal, yeah, the one that we use for barbecue and all. Coal is a form of carbon. Okay, good. To produce electricity in power plants, yeah, to produce electricity. So a large amount of coal is burnt there. All right, so this is a source of, burning of coal is a source of sulfur dioxide, especially coal that has got the sulfur in it. Okay, now the next one, smelting of metal. Smelting of metal refers to extraction of metal. Okay, so who can remember, we have learned before that during extraction of a metal, sulfur dioxide gas is produced. Which metal is that? Yes, it's zinc. Okay, so zinc sulfide, when it is heated in air or roasted in air, you get zinc oxide plus sulfur dioxide. Okay, so during the extraction of certain metals, sulfur dioxide gas is produced. So in this way also sulfur dioxide gets into the atmosphere. It is a pollutant. Okay, it's a pollutant because, you know, it causes diseases to people, and it is considered an ecological threat. Okay, ecological threat means harms the environment, causes diseases and so on. Okay, so it is a pollutant, of course, because sulfur dioxide is a gas. It causes air pollution. What other way does it harm the environment? Who remembers that? It causes acid rain. Okay, very good. Sulfur dioxide causes acid rain. All right, so these are some properties and sources of sulfur dioxide. Okay, so so though it is a poisonous, though it is pollutant, it still has some uses. Okay, so let us see what are the uses of sulfur dioxide. Now, just like sulfur dioxide is also used to make sulfuric acid. Okay, so this is one property which is similar to that of sulfur, and the one that you can easily remember. Yeah, okay. Now it also has some other properties, such as it is used to make pest control product. Okay, so it is used to make those chemicals that can kill pests. Right, now can you give me examples of pests? Termites, rats, cockroaches. Yeah, all these are pests. So it is used to make pest control product. It is used as a preservative in many dried food. What is a preservative? A preservative is any substance that is added to food to keep food in good condition for a long period of time. Okay, so it is used in dried food. Okay, so that's one of the use of sulfur dioxide, and is also used to bleach paper. Where is paper obtained from? From trees. Okay, so when paper is made from trees, it has got a yellow, it has a yellowish color. So when it is bleached with sulfur dioxide, it becomes white. Okay, so most people prefer to have this paper that is white in color. So there it is used to bleach. It is used to bleach paper. Okay, all right. Now, these are the main uses of sulfur dioxide. The other 2 points are just an extension, a bit more explanation on what you have learned before. So, but if you can study these 2 points, that is more than enough. Okay, all right. So since sulfur dioxide can control, it can be used to control, to make chemicals that can control pests. It can also be used to disinfect materials, kill germs such in objects such as wood or straw, and again to eliminate insects and other pests. Okay, now in dried fruit, how does sulfur dioxide work? Sulfur dioxide actually stops the growth of bacteria. Okay, it has the ability to kill bacteria. So the bacteria will not act on the food and spoil the food or decay the food. Okay, so the food will be in a good condition for long period of time. All right, so these are some uses of sulfur dioxide and sulfur. Okay, so far what we saw was the properties and uses of sulfur and properties and uses of sulfur dioxide. Any questions, student, before we move on to the next part? Okay, no questions. Now let's come to the next one. This is the main part of the topic. Okay, contact process. So you must have seen that in this particular chapter we come across a lot of processes. Hall-Heroult process, basic oxygen process, Haber process, and now we have the contact process. Okay, so let's see what's the use of the contact process. The contact process is for making sulfuric acid. Remember, the Haber process was to make ammonia. Contact process is to make sulfuric acid, and just like Haber process, here also you have a reversible reaction. The raw materials to make sulfuric acid are sulfur and water. Okay, now what are raw materials? What do you understand by the term raw materials? Okay, good. They are natural resources, substances that are obtained naturally. Okay, like sulfur is found from under the Earth's crust. Air is the surrounding atmosphere, and water is available on the Earth. So all these are used to make a sulfuric acid. And if you look at the chemical industry, quite a large number of chemicals are made. And one of the major chemicals that come out of this industry is sulfuric acid, because sulfuric acid has a lot of uses in our day-to-day life. Okay, so let's see, later on you will see what are the uses. Okay, so now let's move on to the contact process of making sulfuric acid. Now, though you will see that there's a lot of information here, it extends to one whole page. You don't have to really focus on the stage 1, stage 2. As long as you know the sequence of that equation, which one is first and how the sulfuric acid is formed, that's fine. Okay, so this for you, for easy understanding, it has been separated. Okay, now let us look at the first step. So in the first step of making sulfuric acid, sulfur is burned in air. Okay, so when sulfur is burnt in air, it actually reacts with the oxygen. So sulfur reacts with oxygen to form sulfur dioxide. So the place where in the industry where the sulfur dioxide is made, care is taken to not release the sulfur dioxide in the atmosphere, because as we saw earlier, sulfur dioxide causes acid rain. Okay, so now let's move on to the next one, that is making sulfur trioxide. Okay, so the next step is the sulfur dioxide reacts with more oxygen to form sulfur trioxide. And you can see here that it is a reversible reaction. Okay, so a reversible reaction is one where the reactants form the products, and the products will form back the reactants. Okay, so here, since in order to get maximum product, okay, in order to get maximum product, in order to have more of the forward reaction, what happens is there are certain conditions that are used, like just like the Haber process. Here also you have certain conditions. Is that clear? And you need to know the value, and you need to give the conditions. If you ask for the condition, you must give specific values. Okay. All right, now let us look at what the conditions are. Okay, the conditions are, you need to have a catalyst. Okay, there's a catalyst of vanadium 5 oxide. Okay, it's important for you to write the oxidation state 5. Okay, temperature 450 degrees Celsius, pressure 2 atmosphere. Okay, so if you look at the temperature is same as what you saw for the Haber process, 450 degrees. So you just have to remember one number. Okay, but the catalyst here is vanadium 5 oxide. Haber process catalyst was iron, and here pressure is 2 atmosphere. Haber process, it was 200 atmosphere. Okay, so so these are some things that you have to keep in mind. All right. Okay, now let's move on to the next part. The next part will say how sulfur trioxide is converted to sulfuric acid. Now, actually, sulfur trioxide is a very soluble gas. Okay, it can easily dissolve in water, and that is how acid rain is formed. So, sulfur trioxide plus water, you get sulfuric acid. Okay, so you just have to, when you add up, you can see 2 hydrogen, 1 sulfur, and 4 oxygen. Okay, now but in the industry this reaction is not done, because what happens is, as it says here, the reaction is so uncontrollable. The reaction is so uncontrollable that it creates a fog of sulfuric acid. So that means in the place where the sulfur trioxide is dissolved in water, there will be a cloud of sulfuric acid. There will be a huge, there will be a lot of sulfuric acid particles hanging in the air. Okay, so this is not good for the environment and not also good for people who are working there. So this particular reaction is not done. So instead of doing it in one step, what they do is they do it in 2 steps. Okay, so that it is a safer way to do. Is that clear? So let's see how it is, what the 2 steps are. Okay, so in the first place, what is done is the sulfur trioxide is dissolved in sulfuric acid. Okay, so sulfur trioxide is dissolved in sulfuric acid to form a substance called oleum. Now this oleum formula is quite easy to remember. We just have to add up all the atoms here. Okay, 2 hydrogen, 1 + 1, 2 sulfur, 4 + 3, 7, 7 oxygen. So this is a formula for oleum. So sulfur trioxide is dissolved in sulfuric acid to form oleum. The oleum is then diluted with water to form 2 times more sulfuric acid. Okay, so this is how the sulfuric acid is formed, and these are the different steps in the making of sulfuric acid. Okay, so basically these are the 4 equations that you need to know. Sulfur reacts with oxygen or burns in oxygen to form sulfur dioxide. Sulfur dioxide reacts with more oxygen to form sulfur trioxide. Sulfur trioxide is dissolved in sulfuric acid to form oleum, H2S2O7. Then oleum is diluted in water to form sulfuric acid. Okay, so these are the different steps. So if you study these 4 equations together with the conditions, then you will be able to answer most of the questions for contact process. Is that clear? So you'll be able to answer question for this particular process. Okay, is that clear, students? Okay, any question before we move on? Okay, no question. Now let us look at just like the other substances, sulfur, sulfur dioxide. Sulfuric acid also has uses, and also there are some hazards. What are hazards? What do you understand by the term hazard? Dangers. Hazards are, in simple terms, they are the dangers. Okay, and how to handle it. All right. Now, the majority of sulfuric acid is used to make fertilizer. So the last time when we learned about ammonia, okay, the last time when we learned about ammonia, we learned that the major use of ammonia is to make fertilizers. So ammonia is reacted with sulfuric acid, ammonia is reacted with nitric acid to form fertilizer. So here, the major use of sulfuric acid is to make fertilizers. Okay, so let us see how the fertilizers are made. So ammonia, when it reacts with sulfuric acid, forms ammonium sulfate. Ammonium hydroxide, when it reacts with sulfuric acid, forms ammonium sulfate and water. Okay, so you see the products are the same in both cases. One of the product is ammonium sulfate, but just be careful. If you only have ammonia, which is aqueous ammonia, you have one product. And then if you have ammonium hydroxide, okay, the hydro part here, then you also have water. Okay, so only ammonia, you get ammonium sulfate, you get one product. If it is ammonium hydroxide, you get water as well. Okay, all right, so now let's move on to the uses of sulfuric acid. Now, sulfuric acid is used to make detergents, paints, fertilizers, okay, already mentioned, fibers, dyes, soaps. Okay, detergents repeated again. Okay, what are detergents? Okay, detergents are the soap powder and the washing liquids that we use at home. Okay, so just imagine that each family uses quite a large amount of detergent, isn't it, for a month, let us say. So just imagine the number of families and households that use these detergents, and all these detergents are made from sulfuric acid. Even though if it's not all, most of them, they are made from sulfuric acid. And then if you look at paints, all of these are household items that are commonly used. So that is why sulfuric acid, as I said in the beginning, is a major product of the chemical industry. Okay, because a lot of everyday substances are made from sulfuric acid. Okay. All right, now let's look at fiber. Fibers of sulfuric acid is also used to make fibers. Okay, fertilizers we've seen already. Fibers, like fibers, synthetic fibers that are used to make clothing, plastics, and so on. Okay, dyes, the coloring matter, and also soaps. So all these things are made from sulfuric acid. Okay, now, but at the same time, this concentrated sulfuric acid has to be handled very carefully because it's a very dangerous chemical. Okay, it is a strong dehydrating agent. It's an oxidizing agent, and it can cause severe burns. Okay, so if concentrated sulfuric acid comes in contact with your skin, it can eat the skin away. Even clothing, okay, if it comes in contact, it will, you'll find holes in your clothes. All right, so it is a gas that has to be handled very carefully. Is that clear? Okay, now like even if you see the lab, the dilute sulfuric acid can be, sometimes can be kept on the shelves, but concentrated sulfuric acid has to be kept in a very safe place. Okay, so because it's a highly corrosive substance. Okay, now what we understand by the term dehydrating agent? Removes water. Okay, very good. Oxidizing agent, it oxidizes the other chemical that it reacts. Okay, so concentrated sulfuric acid has got these properties. Is that clear? Okay, I will show you a video which shows the dehydrating property of concentrated sulfuric acid. Okay, so you watch the video carefully, observe the color change and so on. Okay, then we will go to the equation. Are you able to see the screen, students? The one that shows a sulfuric acid and sugar? Okay, good.
Bearded Science Guy here, and today I'm going to show you how to make a dehydration reaction of sugar using sulfuric acid. Start by filling a glass container about a third of the way full with either granulated or powdered sugar. Now pour in roughly the same volume of concentrated sulfuric acid, but be careful, concentrated sulfuric acid is one of the most corrosive compounds out there and can cause instantaneous tissue damage. At this point, carefully stir the mixture until it's the same throughout, and then watch what happens. The sulfuric acid breaks apart the bonds that holds the sugar molecule together, converting it into elemental carbon and water. But again, be careful, because sulfuric acid is one of the most dangerous compounds out there, and you need to make sure to use proper safety protocols.
Okay, so that was a video about the dehydrating property of concentrated sulfuric acid. Now, who can tell me the concentrated sulfuric acid reacted with what substance? It reacted with sugar. Yeah. Okay. So yes. So let's look at the equation, look at the theory part now. Now, sugar is a carbohydrate. Carbohydrate means it has got carbon, hydrogen, and oxygen. Okay. Now, when water is removed from the sugar, what is left behind is only the carbon. All right. So sucrose is a form of sugar, and this is a formula for sucrose. So when sucrose reacts with concentrated sulfuric acid, it removes water molecules. All right. And what is left behind when the water is removed? Only the carbon is left behind. Okay. Now, why 11 water? So the 11 times, okay, water is H2O, right? So 2 times 11 is 22 here. And 1 times 11 is 11. Is that clear? So this is the equation for the dehydrating property of concentrated sulfuric acid. All right. So when the hydrogen and oxygen are removed as water, what is left behind is carbon. And if you have carefully observed the video, you can see steam coming out. Now, this is because this reaction is highly exothermic. So that means heat is given out. So the heat given out vaporizes some of the water. Okay, so that is why you see the steam. Clear? So the reaction is exothermic, and the white color sugar becomes black. And like it says here, you can actually see the carbon being pushed out of the container. Is that clear? So this is an example for the dehydrating property of concentrated sulfuric acid. Okay, so with this, we finish unit 9.4. All right, any questions on unit 9.4, students? All right, okay, no questions. So if no questions, let me summarize what we learned today. Okay, so today we learned about the uses and properties of sulfur, sulfur dioxide, and sulfuric acid. And then we also learned about the contact process whereby sulfuric acid is manufactured. And we also looked at the dehydrating property of concentrated sulfuric acid. Okay, all right. So if no questions, let us move on to the homework part. Okay, so the previously I asked you to do question number 3 and 4 from page 249 of the textbook. Okay, so now you need to answer question number 5 and 6. Okay, so let's look at question number 5. Okay, question 5. The diagram shows a basic oxygen converter. This is used to convert impure iron from the blast furnace into steel. During the process, some of the impurities in the iron are converted into slag. Okay, basically this is what you have learned before. It's the basic oxygen process. Okay, now label a copy of the diagram to show each of the following. So you can draw the diagram. It's quite a simple one, and then you label it. Okay, now where will you write 1? Where will you write 1? At the top. Okay, so you have to write at the top. Now I have written 1 because there's not much space, but when you label it, you have to write where the oxygen enters. Okay, so that is what we call as labeling. Don't just write 1, 2, and 3. Okay, now what is this? This is the slag. Okay, good. What about, and obviously this is the molten steel. Okay, all right. Now let's move on to question 5b. In the converter, the oxygen oxidizes sulfur, carbon, and phosphorus to their oxides. Explain why sulfur dioxide and carbon dioxide are easily removed from the converter. Okay, who can give me the answer? It's 1 mark only. Good. Sulfur dioxide and carbon dioxide are gases, and therefore they leave the converter. Okay, so that's all. It's only 1 mark. So sulfur dioxide and carbon dioxide are gases, and they leave the converter. Okay, look at the next question. It's 3 marks, so you need to write three relevant points. Explain how calcium oxide is used to remove phosphorus 5 oxide from the converter. Okay, who can answer? Okay, good. Calcium oxide, you need to write all this. Yeah, calcium oxide is a basic oxide. Phosphorus 5 oxide is acidic oxide. The two react together to form calcium phosphate or slag. Okay, and slag is removed from the converter. Okay, so in this way, so what it means is that the phosphorus 4 oxide is converted into slag and it is removed. So that's the idea there. Okay, so let me repeat once again. Calcium oxide is a basic oxide. Phosphorus 5 oxide is acidic. The two react together to form calcium phosphate or slag, which is removed from the converter. Okay, now moving on, let's look at the next one. Stainless steel is an alloy. Which one of the diagram A, B, C, or D best represents an alloy? Okay, what's your answer? Okay, D. Yeah, yes. Why D? Because if you look at A, now here it says stainless steel. Stainless steel is an alloy. Okay, so stainless steel contains iron, chromium, and nickel. So when you look at diagram A, there's only one type of atom. So it can't be an alloy. When you look at B and C, there are two different types of atoms, but there's an orderly arrangement. There is a regular arrangement. Okay, so in an alloy, there is no regular arrangement. The orderly arrangement is not there because it's a mixture of different atoms. So when you look at D, you have more than one type of atom, and at the same time, there's no orderly arrangement. Okay, now state one use of stainless steel. Okay, you've learned quite a number of uses. You can write any one. Yes, very good. Someone has said to make cutlery. Yes, good. Okay, now we do not have that much time to discuss question number 6, but question number 6 is quite an easy one, and it's about the extraction of zinc. So you can, if you refer to your notes, you can get all the answers for that particular question. Okay, so for your homework, I want you to do question number 5 and question number 6. Okay, so in your class WhatsApp group, I'll share the link. Okay, I will also give you the link now for you to upload your homework. Okay, so that's the link for you to upload your homework. Is that clear, student? So please complete your homework and then upload it. All right. Okay. Any question before we end this session? Okay, no question. No question. See you all in the next class. Okay, bye.